Okay, thank you. Then I'll be.
Yes, Doug, I can
I'll.
hear you.
Yeah, thank you so much. Also, I think you can see my screen. Okay.
Clear, Doug. Clear.
Yeah, thank you. So now let me start my presentation. So we have today the second workshop on workshop series on data analysis using JASP, JASP. So today we are going to see the t-test analysis. The last first workshop in this series, we have seen about reliability test as well as correlation. The next series, today we are going to see the t-test analysis. Also, we can say is a hypothesis testing. So these are the learning outcomes. After completing this workshop, we can understand the purpose of t-test and differentiate the different type of t-tests and perform the t-test according to a need using the JASP software and interpret the results and apply the t-test in the real world scenarios. So these are the learning outcome intended for this workshop. So what is the t-test? Basically, the t-test is used to compare the means of two sample data. What aspect we are going to compare? So for example, we are having coursework 1 and coursework 2. So I want to do the survey on how student performance. I want to analyze the student performance in coursework 1 as well as coursework 2. So first I take the coursework 1 mean and coursework 2 mean. So I'm going to compare these two mean. So to know whether there is a statistically significant difference between these two mean or not. So that is called t-test. Also, it is called hypothesis testing. Okay, hope you understand. We have two assessments, and the mean of assessment 1 and mean of assessment 2. We are going to compare these two means. Okay, after comparing, let's say the mean 1 is a 10, and the other group has a 9.8. So we may say that small difference is there, but we need to see whether it is statistically different or not. If it is statistically different, then we may agree that, oh yes, there is a difference between these two groups. Otherwise, we can ignore the differences because the difference is very less. So that can be done with the help of this t-test using the software called JASP. Okay, there are three different types of t-tests under three different scenarios. So let's say the first one is one sample t-test. So what does it mean, one sample? Here we have the sample collected at that moment. We are going to compare the mean of the sample with the existing mean. For example, this semester, fall 24, I teach college math, let's say that. So I wanted to see the overall performance of college math comparing with the previous semesters or past semesters. So the past semester mean is existing already. Now I have only one sample, the fall 24 sample. So I'm going to compare with the previous one. That is called one sample t-test. The next scenario is, the case is independent sample test. Here, independent sample test means we have two data which are independent to each other. They don't have any relationship. For example, same module, college math, teaching in session A and session B. So I want to compare the performance of students in session A and B. So session A students are completely different from session B. This is what we say that independent sample t-test. The third case is dependent sample test. This is also called paired sample set. So for example, the college math, we don't have only one assessment. We have coursework 1, coursework 2, and coursework, end semester exam. So there are three assessments. Let's say that within the same session, for example, session A. So same students wrote coursework 1 in week number 6. And for example, coursework 2 in week number 12, and final exam in week number 16. So same students done the 3 assessments at 3 different periods. So now we are going to compare the performance of this, which assessment the student done good in which assessment. Yeah, that is called paired t-test. I hope it is clear. So these are the 3 categories of t-test. These are the formulas for one sample t-test. We are not going to use this formula since we are going to use the software directly. We are not going to use the formula manually. This is the formula for one sample test. This is the formula for independent t-test between 2 sample. And this is for the paired sample t-test. Okay. Now we come to that conducting the t-test, the procedure to conduct the t-test and interpret the results. So first, we need to write that hypothesis. I will come to the next slide. What is that hypothesis? How we write it? For example, what I said before, I'm going to do for independent test. That means session A, the mean of session A, I'm going to compare with mean of session B. So is there any significant difference or not? I'm going to do it statistically. So always we say that null hypothesis. There are 2 hypotheses. One is called null hypothesis, which is called H0. The other one is called HA, which is called alternate hypothesis. The null hypothesis saying that there is no difference between session A and session B. That means there is no difference between the mean of session A and mean of session B. That is called null hypothesis. The alternate hypothesis says that there is a difference. There is a difference. Okay. Yeah, it could be higher or lower. When we say the difference, it could be more than session A or less than session A, like that. Yes, exactly. So then you need to choose a significant level. That means at what confidence level we say that. At what confidence level we are going to say. So up to 95% confidence. At the rate 95% confidence, my results are correct. At 90% confidence, my results are correct. Like that we can say. This is what we say that significance level. We can choose this one. So basically, we choose alpha equal to 0.05. It is a standard one. Most of the statistical analysis are performed by using this significant level. Okay, then we need to see the p-value that we are going to get from the software, and we need to take the decision whether p-value that is obtained from the analysis is less than alpha or greater than alpha. We need to check. If it is less than alpha, we need to reject null hypothesis. Remember? Yeah. If it is our p-value obtained from the statistic analysis is less than the alpha 0.05, we need to reject null hypothesis. Otherwise, we need to accept the null hypothesis. If it is greater than or equal to alpha, we can accept the null hypothesis. Okay. The null hypothesis, alternate hypothesis are mentioned here. The null hypothesis always we say that there is no difference, there is no effect between 2, like that. We try to say equal. Or alternate hypothesis saying that no, there is a difference. Okay, always opposite to the null hypothesis. And significance level, I told you already, commonly we said it is 0.05, which means 95% confident. Okay. Conducting the t-test now. And before conducting the t-test, we must see whether the data is normally distributed or not. That I have explained in the previous workshop, whether normal distribution or not. So if it is not normally distributed, that is called non-parametric analysis. We need to choose a non-parametric analysis. In the non-parametric analysis, these are the tests we need to choose. Mann-Whitney for independent samples. For independent, 2 different samples, mean of two different samples. We are going to compare. And Wilcoxon find rank test for paired samples and one sample test. If it is non-parametric. Otherwise, we can choose the student. There is one more test called student test. It is for normally distributed data. So what are the common pitfalls here? I mean, might be some errors in the t-test. Using the t-test with the non-normal data, that's what. You may assume it's a normal data. Actually, it is not normally distributed. So you have to choose the appropriate test. If it is not normally distributed, we cannot choose a student test. We need to go for Mann-Whitney for independent, otherwise Wilcoxon for dependent and one test. And incorrect use of a paired versus independent test. For example, we have the two sample data, we may understand it. Same class and coursework 1 and coursework 2. When we are going to compare, we must choose dependent test, not independent test. So by mistake, they may choose, okay, since we have the two data, we may choose independent. That's not correct. We must choose dependent. As long as data is from same, yeah. And misinterpretation of the p-values. For example, p-value is less than alpha, we may accept null hypothesis. We supposed to reject. P-value is less than 0.5 means we have to reject the null hypothesis. So that is the wrong interpretation. This is what the brief introduction about sample. Now I'm going to what do you call that, demo by using the software. So any doubts from the slides? Shall I continue? Okay. Now I'm going for the software. Is it? Yeah, this is the software here. Can you see my? No, you couldn't see, right? Okay. How to share my screen again? Yeah, we have to share different one. We share. Okay. Okay. You can see now, right? Can you see my screen? Yes, good. Thank you. Saying minimize, but it's not minimizing. Okay. So now I have the data. You can choose any one of the data. Let me explain all these three sample tests. So first we need to go for descriptive statistics of one sample test. I mean, I'm going to give you one sample test. What does it mean, one sample test? The previous population mean is existed, and now I'm going to compare with the current with the previous one. Okay, so I have the data. For example, this data score. So I have the score, only this column. You just consider only this column. Yeah. So some numbers are there. I have the data. We need to keep this in the scale range. There are different ordinal, nominal, and scale. So this is scale. I'm going to take only this data. First, I said we need to test for normality, whether it is normally distributed or not normally distributed. So we need to know that. So for that, I have done descriptive statistics. Descriptive statistics, you can see here after selecting the score, I've selected this variable I'm going to select and go for descriptive statistics, then automatically you will get it. Okay, so you can see that how many samples are there, valid 16 samples are there. and mean value is 11.38, standard deviation 3.8. The mean value is 11.38, standard deviation 3.8, and this is the Shorpier-Wilk. It's called normality test. This is the test to know whether the sample is normally distributed or not. The p-value is given here. A minimum and maximum is there. Minimum is 4 and maximum is there. So p-value is 0.01. So I have given this interpretation. When the p-value of the given sample is less than 0.05, that is not normally distributed. It is not normally distributed. I don't know, let's choose a color. It is, yeah. So that is not normally distributed because of p-value is less than 0.05. So we need to go for which type of test? Non-parametric. Non-parametric. So the next is the one test. So I go for one test. One sample t-test. I have done it already. So I'm taking the same score again. Okay. And you can choose. See, this is the test. If it is normally distributed, then we have to select student. No need of Wilkerson. Since it is not normally distributed, then I need to go for Wilkerson. No need of student. The moment you click here, you can see the value will be keep changing. And also you can select alternate hypothesis. Alternate hypothesis, you have the option in this software. This is the beauty of this software. This facility is not even available in SPSS. So alternate hypothesis, we are saying that it is not equal. Hypothesis, null hypothesis saying that equal. What do you mean equal? The mean of the current sample is equal to the mean of the existing population mean. Now we are saying not equal. So you can say that here the, what do you call it? P-value is there. What I said before, the p-value less than 0.05, which is alpha, we have to reject null hypothesis. What is null hypothesis? They are equal, but actually they are not equal. So it's given here. So for this test, the alternate hypothesis says that the mean, what do you call, the median is different from 2. That means why I said, here I said the 2. If you said 5, for example, it will change it. Different from 5. So what is meant by the 5 and 2 here? The previous known mean value. The previous known mean value. You can set here. Or simply you can say that since the p-value is less than the alpha, which is 0.05, we have to reject null hypothesis. This is what we say that one test, one sample test. The one sample test, we must have the mark in a single column continuously. Yeah. Okay, now I'll go for the next one. One till is finished, then I'll go for the next one. Yeah, paired sample. Here, paired means, as I said before, I'm going to compare the same students' performance in different assessments, coursework 1, coursework 2, and so on. So here I have done the 2 assessments. One is called pre-test, other one is called post-test, like coursework 1 and coursework 2. So I'm going to see the performance of students in pre-test as well as post-test. So you can see the what do you call that? First is always, I said, descriptive statistics is must. Choose the descriptive statistics after choosing the score value. The score, the same one. Here I have grouped the score into some of them are pre-test, some of them are post-test. Now I'm going to choose 2 columns. So score goes to the variable and split the group. This is the group. You can see the data here. group. Under the group, I have two categories. One is called pre-test, other one is called post-test. So the group goes here, then we'll see this table. Under this code, I have the pre-test and post-test. So what is the p-value? For p-value, for the pre-test, it is closer to 0.05. Sorry, it is greater than 0.05. Right? You can see this one, the p-value greater than 0.05. So which means it is normally distributed. But here it is less than 0.05. So it is not normally distributed. So both the cases are there. In such a situation, we need to go for non-parametric. One data is normally distributed, other one is not normally distributed. So we must go for non-parametric. Non-parametric means Wilcoxon test. I given here Wilcoxon test. So the paired sample test. So you can see the paired sample test. So I'm taking the score here. The moment I took the score, it has splits, right? Groups are there. So pre-test and post-test, we will compare pre and post. And we got to choose, as I said before, don't choose a student, we got to choose Wilcoxon. And measure, I have alternate hypothesis. I mean, mean 1 is not equal to mean 2. This is called alternate hypothesis. Null hypothesis saying that mean 1 is equal to mean 2. That means mean of pre-test is equal to mean of post-test. Okay, after that, so this is the sample. So here I have measure 1 pre-test, measure 2 post-test, and some numbers are there, degrees of freedom are there. Now look at the p-value. What's the p-value? P-value is 0.8. So if p-value is less than 0.05, we have to reject null hypothesis. If p-value is greater than 0.05, we cannot reject null hypothesis, right? So we have to accept null hypothesis. So now, what is null hypothesis saying? That there is no difference between the pre-test mean and post-test mean. Although you can see the mean value here from the, from where is that? Yes. Yeah. 1 minute, sorry. These are, I have done 2 paired tests. That's why it's coming like that. Yeah, this one. You can see the mean. One is 10.7, other one is 11. We can say 11.9. There is no much difference. Yeah. So that's why we are saying that there is no statistically difference between these two mean. That's why null hypothesis, which says that there is no difference in means of pre-test and post-test, cannot be rejected. So we have to accept it according to this p-value, because here the p is greater than alpha. Yes. Sir, is it possible to compare only 2 test sample? No, it can be more than 2. That's why I given another example with the same paired test. Paired test. Here you can see how many paired CBT1, I mean coursework 1, coursework 2, and end semester exam of same students in same session. Let's say that CBT is week number 6, lab test week number 12, and end semester exam in week number 16. So how they perform, you can see that. So what we have to see, the p-value of each sample data CBT, it is 0.05 exactly, and it is less than 0.05. It is greater than 0.05. So it's mixed like before, normally distributed and not normally distributed. So as I said before, if any one of the data is not normally distributed in the sample, so we need to go for non-parametric. So we have to go non-parametric. So this is the paired T sample. Yeah. So I have taken here CBT, lab test, and different pairs are there. CBT and lab test, and CBT and end semester exam, lab test and end semester exam. So these are the different combinations. And I'm going for Wilcoxon. Actually, I have selected students also. You can ignore the student. since the mix, some of them are what do you call that? Normally distributed, some of them are not normally distributed. That's why I have taken both, but you can consider only Wilkerson. Okay, but you can see that's almost same. You can see the first is the student, that's also less than 0.005, so less than 0.05. Both p-value is less than 0.05. I mean less than alpha. If it is less than alpha, what we can do? Reject null hypothesis. So all the cases we can reject null hypothesis. Okay. So this is all about dependent t-test or paired sample t-test. Now the third case, independent sample. You can see the independent, the moment I say, I have used a different session A, session B. I didn't say that coursework 1, coursework 2. Yeah. So I'm going to compare that coursework of session A with session B. They are called independent. You can see that again. So one of them, I mean, session A is not normally distributed. Session B marks are normally distributed. So we need to go for non-parametric test. So independent samples for non-parametric. Wilkerson is there. Sorry, Mann-Whitney. For independent, we need to choose Mann-Whitney. But I have chosen all. Student is there, which is there. This is the important thing. You can see this one. Almost all of them are giving same p-value, right? But the most reliable is the Mann-Whitney for independent t-test. So it is 0.03, which is less than alpha. So what does it mean that? Reject null hypothesis, which says that there is a equal between, I mean, mean is equal between the session A and session B. That is a null hypothesis. But alternate hypothesis saying that it is not equal. So it is not equal. We can see very clearly from this mean, which is the mean. One is 27, session A is 27.7, session B is 23.05. So we'll say that 23.1. We can see very clearly there's a huge difference between these two means. But still we need to claim, we need to have t-test analysis to concretely say whether there's a statistically difference or not. So now it's very clear there is a statistically difference between the mean of coursework marks between session A and session B. Now, if your software is ready, you can just open and you can download any one of the data. Let us assume one is the session A, other one is session B. Or you can even compare if you are teaching two different modules. So same teacher, I want to know my performance in different modules. So you can also compare like that. But still 10 hours, maybe it's very, yeah, maybe slow internet. Any other doubts, my friends? Amal, any one of you have this software? JASP software. If not, you can download it. I will share with my. This is the software. Also, you can work from internet. This is the option. Not getting minimized. This is the option. We will share it in OneNote. Sorry, MS Team now. You can download or you can work on online. Both is possible. So just download and you can download some of the data from SAS. Even the previous semester essays data you can download, marks, semester marks, compare with the two modules. This is easy to edit the software. I mean, I edit the data very quickly. If you want to create a new one also, you can create a new one. Then you can go for the new data. Click column one, how to edit column, double click on that. Then you'll give the name for that. Double click and give the name for that. What is the name? First one is score. Then double click, it will give. If it will be there. And the next one, if you want to click, double click the column, here will be there. Maybe you can make it, okay, let's say that, let's say this is a, I'm going to select group, this is scale, and score, I can say that score. Or depends on the test we are going to do that. If you use group, we can go for the paired test. If you use, what do you call it? Yeah, session A, session B, we can select it like that. Then you can copy that. Here I'm going to, you can close it then. So here I can say that it's, what do you call that? Pre-test, retest. Is the class here? Okay. You can copy and paste. What's the time now? It's 4 almost. 3:45 only. Yeah. Okay. The pre-test, and I'm going to say the post-test, like that you can. If you have a data already in Excel, you can copy and paste here. It's easy for you. That's what I suggested. Okay, so I'm just giving some number. Say that considering I'm 10, okay, 11, 12, 13, 14, and again, let's say that 15, 16, 13, 20, and 11. 11, yes. Why it is called? Oh, it is getting closer. What is my software? It's here, okay. So now, yeah, analysis, just go there. First, descriptive study. I'm going to select the score, go to the variables. And if you want split, you can put this group here. So you can see very detailed here. Yeah, so you see that pre-test, okay, post-test and group is not there again. I think it's, yeah, it's repeating again. It's coming 2 times. I don't know why it is repeating 2 times. Post-test, post-test. Okay, maybe I written something. Yeah, pre-test wrongly. Yeah, see the capital T, small t, it took this is the way. So I need to go and edit it. I would use the same one. I would use the same one. Pre. No, this T is missing. Yes. Now it's okay. Yeah, see, you can see that very clearly. Yeah. That's why I better to use copy paste rather than typing. We may have some spelling mistake, typo error. Yes. Yeah. Yeah. Now this is the dependent samples. So you can see that, but I have not mentioned that, right? Normality test is not there. So I need to go for statistics, open statistics, and select a normality. Is that normality? Yes, this one. Distribution. This is with the normally distributed or not. So this one is need selected. If you select, you will see this more. See 0.97 and 0.92. So both of them are above. No, this is normally distributed. Normally distributed. If it is less than 0.05, it's not normally distributed. So now we can go for t-test. The next one is t-test here. Click on that. Classical. We always choose the classical, not Bayesian. So here we are going for paired sample test. So select the paired sample. So I'm going to select that variables pair. Group will not go there. Core. Why it's not having the pre-test? Okay. For that, I need to have pre-test and post-test separately. I need to go for different test. It's not taking the group is not taking there. So I need to create different one key value only. So I need to tell 3 and 4. So it means copy. Yeah, I create a new one. Let's say that's a pre-test. Okay. Yeah, this is finished. Now go for it is rank. Okay, I need to select. So I'm going for post test. Yeah, have it. Now let me select. So I need to select. I will take the score away. So now you can see very clearly. P is 0.17. So it's greater than alpha. Alpha, we said everything by default is there. Alpha is there, 95% confidence level. So by default is there. So we are saying that the mean, you can see very clearly, although the mean for pre-test is 12 and post-test is 15, there is no significance difference between these two means because we have to accept null hypothesis because it's greater than alpha. When it is greater than alpha, we need to accept null hypothesis. That is the data analysis interpretation. If it is like two different datas, two different sessions, like session A and session B, or class 1 and class 2, we need to go for independent test. And if it is a non-parametric, we need to select here Wilkerson. You can see this very clearly. Yeah, this is the student test 0.17 and Wilkerson also 0.18. So almost very close. So both the cases we need to accept null hypothesis because alpha is greater, P is greater than alpha. Yes. So in such a way, you can download the data from your SAS, yeah, apply it here. So simply you can do some analysis within your model. Also, you can use this for your research. Yes. So we'll see the next topic in the next workshop series, part 3. I hope you all enjoyed.
Thank you
If
so
you have
much.
any questions, yeah, any questions, feel free to ask me even after the session. Now students started coming to class because they have the class at 4 o'clock. Okay, thank you.
Thank you too.
Yeah,
Thank you very much, Doctor.
bye. Bye. Yeah, please. Yes.